Hey, algebra students. Here in lesson 3, we're going to do the last of our conic sections. We've talked about circles earlier this year. We've talked about parabolas. Last lesson we talked about ellipses, and we finish off with hyperbolas. Hyperbolas, you're going to see, are very closely related to ellipses, and so if you felt confident with ellipses, which it seemed like you did, you're going to do just fine with hyperbolas. So learning target number 5, be able to graph hyperbolas, and then learning target number 6, write equations for hyperbolas. Okay, we have a lot of similarities between ellipses and hyperbolas, including kind of a weird definition. With hyperbolas, we're going to say it's the set of points, and then instead of being the sum of the distances from the fixed points, it's going to be the set of points that is the absolute difference so the absolute value of the difference of the distance from two set points. And of course, you know that these foci are the set points. So if we take a look at our graph here, you know, any random point on our hyperbola, all of these points are going to have something in common, in that if we take this length minus this length, subtract those, either way, so small minus the big or big minus the small, since we're taking the absolute value, it's going to wind up being the same thing. And so if we take these two things and subtract them, that value is always going to be the same. And those two fixed points, like we said, are the foci. And the foci are going to be c units from the center. And then a couple other things. We had, with ellipses, we had the major and the minor axis. And the major axis was the one that the foci were on. Well, here, the transverse axis would be kind of like your major axis, in that this is the axis that is always going to have the vertices on it. So we can have versions like this where the foci are on the horizontal axis, and you know they look like this, or they could be on the vertical axis, and then you've got them kind of go in that direction. All right, let's see, the foci. Well, if you remember with ellipses, with an ellipse, that c distance could be found using c squared was equal to a squared minus b squared. And we just had to remember that a squared always had to be bigger than b squared. Well, for the hyperbola, we have a similar but slightly different version that will help us find the c value. And we're going to say c squared is equal to a squared plus b squared, which would make sense since you can kind of see the right triangle in there, and a squared plus b squared equals c squared. All right, and so there we go. The vertices, obviously, those are going to be these points right here, and so. All right, next slide. Parent function. So like we had a basic version and then the version with a shift with ellipses, we have the same exact thing with hyperbolas. And so with hyperbolas, we can go ahead and say it's actually the same function, except we're going to say x squared over a squared minus y squared over b squared is equal to 1. So you can see the key difference here is we have a minus sign instead of a plus sign. Another thing, just so you know, if we have something that leads with an x like this, the lines, our graphs, are going to go through the x-axis. So we'll say through the x, not always the x-axis, but yeah, through the x or the horizontal. Okay, if we switch this around, which we didn't do with ellipses, but if we go ahead and say y squared over b squared minus x squared over a squared equals 1. Okay, this actually switches things up, and we wind up having things through the y-axis. And so just to show you, it's going to look like this when we lead with the x, and it would look like this when we lead with the y. So that's how we are able to tell whether or not our function goes this direction or this direction. All right, now a couple of other key things. The asymptotes with these hyperbolas, so you can see that we would wind up with asymptotes, kind of like these right here. Right? Well, the equations for these asymptotes are simply going to be y equals a over b, positive, negative. So, you know, the positive version will give me that, the negative version will give me that, and these are going to be real great ways for us to be able to kind of border in our hyperbolas. Here we're going to graph the hyperbola, we're going to sketch the asymptotes, we're going to find the coordinates of the vertices and the foci, and we're going to give the domain and range. So a lot going on here. Notice that really all we need to do to graph this one is we need to figure out the square root of 25 and the square root of 49. Those are going to be our key points, just like they were with the ellipses. So take the square root of 25 and I get negative 5 and I get positive 5. I know that because I lead with the x, these are going to be my vertices, and so it's going to be something that looks like that. In order to help with the asymptotes, we take the square root of the 49, we get positive and negative 7, and then essentially we can just make a box using these key points with the 5s and the 7s. So we are going to draw our asymptotes going through the origin. Notice we didn't have any shifts with the x or the h or the k. So we are free to just go through the origin here. All right, so we sketched the asymptotes. Find the coordinates of the vertices. I guess we've already found those. We can write those down. The vertices, those are going to be at negative 5, 0, and positive 5, 0. All right, so we can just go ahead and use our asymptotes and these vertices to go ahead and sketch the function. So we'll just come in along here. Remember, it's going to get infinitely close to this line, but never actually touch it. And we'll just touch the vertex there, and then head back on out. And then we'll do the same thing over here. We'll get infinitely close to that line, never touch it. We get the vertex, and then we'll head back on out. All right, so there's our function. Find the coordinates of the vertices. We've done that. The foci, remember with the ellipse, we had the c squared equals a squared minus b squared. Well, with this one, we have c squared is equal to a squared plus b squared. And so that means I've got 25 plus 49, which is going to be 74. And so c is equal to the square root of 74. So the square root of 74, I believe that'd be about 8.6. So from the center, we're going to go left and right, 8.6. So I guess it'd be right about here, right about here. And we can write down the foci. Maybe look a little more official, keep the radical in there. We'll say negative radical 74, 0, and positive 74, comma 0. All right, domain is a continuous function, so we'll say all real numbers. And then we're going to say x is less than negative 5, or less than or equal to negative 5. Or x is greater than or equal to positive 5. And then the range, well, you can see we're going to go forever up and forever down. And so we'll just say all real numbers. All right, and we have sketched a hyperbola. All right, moving on. Just some variations on these problems. You can take a look at this one. You see, well, clearly it's not equal to 1, and that's one of the prerequisites. So we just do the same thing that we saw the other day, and we'll divide by 100. 100 divided by 100 is 1, so that's nice. 25 divided by 100, that'd be 1/4. So you just wind up with y squared over 4 minus 4 divided by 100 would be 1/25. So we got x squared over 25. All right, well, here we see that we have a lead of y squared, which means we're going to have something that looks that. And then, again, key points. We've got positive negative 2 square root of 4. And we know that these are going to be our vertices. The other helpful key point will be the square root of 25. And so we've got negative 5 and positive 5. Again, we can make our box here to help make our asymptote. So we'll go again through the origin. And again, make sure that you don't overstep here, and we're just going to follow along our asymptote and hit our vertices both on the top and the bottom. And there it is. So give the domain and range. Again, domain, in this case, you can see that we're going to go all real numbers, go forever left, go forever right. The range, well, this time we do it but with y's. So again, we'll say all real numbers, and then we'll say y is greater than or equal to positive 2, and y is less than or equal to negative 2. All right, so that takes care of that type of example. Here's one with a little bit of a shift, and again, this is nothing to be afraid of. We're just going to do the same thing, just with the center in a different spot. So we do, again, the opposite of the sign, so it means we're going to go, let's see, the opposite of going +2, down 2, and then the opposite of +3, -3, so down 2 and left 3. And again, we see that we lead with the y, and so that means we're going to have something that's this shape. And key points. The square root of 9 is 3, so I'm going to go up 3, and then I'm going to go down 3. So these are my vertices. That helps. And then to help make my box, to make the asymptotes, I've got positive negative 2, so I'm going to go 2 to the left and 2 to the right. I'll use these points to help make my box. Point there, there, here, and here. And then again, just like before, but now I'm going through a different point rather than the origin. And again, just like before, we're going to stay within the bounds of our asymptotes. We're going to hit our vertex, and then we'll slide back on out. Same thing down here. All right, give the domain and range. We've done that a couple times now, but we'll just go ahead and finish this one off. The domain is going to be all real numbers. And then the range is going to be, well, it looks like the one right here is positive 1. So we'll say all real numbers, y is greater than or equal to 1. And we'll also say y is less than or equal to negative 5. All right, this wraps up hyperbolas and our conic sections. Finish up your concept check, and then you can work on the practice